Roswell Flight Test Crew, here at Exponential 2021 in Hotlanta, Georgia. And I'm talking to Patrick Fletchall over at the Wibotic booth. How you doing, Patrick?
I'm doing fantastic. How are you doing?
I'm doing good. Now, I understand you guys do wireless charging?
We do. We do autonomous wireless charging for mobile robots, aerial robots, and a host of other kind of applications.
But hasn't wireless charging been around for a while?
It actually has. In fact, wireless charging was originally invented by Nikola Tesla in 1799, but then he had his funding pulled by J.P. Morgan, so that was the end of that.
Oh, darn. I'm guessing there have been some improvements in the past 300 years.
There definitely have, and that is something that we've worked very hard on creating a safe, reliable, and universal wireless charging system for a lot of different applications.
So what's so special about it?
That's a good question. So one of the things that makes our wireless charging special is both the usability of it in terms of its application to being able to work agnostically with universal type of batteries, but also the safety and reliability of it. With the reliability, there's no contact pins to be hammering together, there's no oxidization of contact surfaces, and then it's also very safe because the system knows when it's in relative proximity with each other, so it's not just constantly pumping out, wireless charging RF all the time.
And how does it know when there's a robot or a drone there that wants to take on a charge?
So each system, both the transmitter and the receiver side, are equipped with a bidirectional radio, which can anticipate and sense where they are in relative proximity. So when the robot or drone approaches, it does kind of a little wireless touch through the air, knows that where it is, and then the onboard charger tells the transmitter what charge it expects based upon its configuration, and then the transmitter delivers that and is able to dynamically amplify how much juice it's sending out over RF based upon where the robot has approached it.
All right, and then what sort of hardware do you need to make this work, both at the base station and, on board the drone, the robot, whatever?
It's actually quite simple. If a sales guy like me can actually set it up, you know it's got to be simple to use. So there's really just four main components. There's the transmitter hub, which then is transmitted via a transmitting antenna, and then that is received wirelessly by a receiving antenna, and then that is translated from the onboard charger directly into the battery. So it's really simple setup.
It looks like most of your receivers are used for fan cooling, but you've got one here that looks like it doesn't require fans. What's that one for?
That is one of our newest onboard chargers called the OC262, and that is our first passively cooled onboard charger, which makes applications for lots of different kind of applications like underwater or areas that may be exposed to the outdoors, like an outdoor robot or an outdoor drone.
Any other unique environments you could apply this technology in?
Out of the world kind of technologies. In fact, our new onboard charger, because it's passively cooled, is right now being tested for use on the new lunar rover, which is going to be trolling around on the moon.
That is so cool. All right, Patrick, well, thanks so much. It's fascinating technology. We'll be keeping an eye on it.
Thank you very much. Good talking to you.
All right. And from Exponential 2021 in Hotlanta, Georgia, this is the Roswell Flight Test Crew signing off. Thanks again.